Hello, we're back on Watkins Waggles looking at C2 Chemistry higher tier calculations again. We're going to go through another example of how to do a reacting mass calculation. So if you want to do this with me, you will need a copy of the May 2014 exam paper, that's C2, and obviously it's a higher tier calculation. So if you're doing foundation, you can switch this off and go and find a more productive video to watch. So, reacting masses. First thing we need to remember again is we're looking for those questions that are asking us to calculate the mass of something, a named chemical, needed to produce a known mass of something else. So they're going to give you one mass, they're going to give you two names of chemicals, and remember we're looking for those clues. There's a balanced equation somewhere in the question, and you're likely to be given the atomic mass or the formula mass of some of the chemicals or the elements involved. So in this 2014 paper, you should be able to skim your way through it and make your way to question 4b part 3. I can spot that this is the question I need because it's asking me to calculate the mass of magnesium oxide needed to produce 1.2 tons of magnesium. So I've got my two chemicals and one mass that I've been given. The clues there, the relative atomic masses have been given to me, and as always it's worth 3 marks. Okay, if it's not worth 3 marks, they're asking you to do something else using your simpler math skills. We did say there's going to be a balanced equation. So where is it? It's not with this part of the question. But if you look back to the top of the page, there's the balanced equation that we need. Okay, so we can easily spot what we need to do, and then obviously we now need to remember what the method is for actually doing it correctly. So we've spotted our question, calculate the mass, okay, and we're focusing on magnesium oxide and magnesium. Okay, so we focus on our balanced equation, which is up here. And again, the first sentence, like you saw in the last examples, will tell us about the equation. Magnesium can be produced from magnesium oxide. So there's our magnesium oxide, and here's our magnesium. Those are the only two things we need to worry about. We can forget about the rest. So what's the memory technique for this calculation? B-MAMRU with a triangle. And we are going to need our formula triangle that they're not going to give us in the exam. So perhaps the first thing you might do when you open your exam paper is to write that down somewhere on the exam so you can use it if you need to. Right, B-MAMRU. I'm going to write that on my exam answer to remind me what to do. And I'm going to write out my triangle MMR in alphabetical order so I can use it later on. Okay, right, balanced equation. First thing I do, I write down the information from the balanced equation, just for the two chemicals they've told me about. So magnesium oxide, I copy big numbers and the smaller numbers, exactly as it says, and then magnesium. Right, M. Just like MAMS, M is for mass. What masses have they given me in the question? So 1.2 tons of magnesium. This is the magnesium, 1.2. We don't yet know what the mass of the magnesium oxide is. That's what they've asked us to calculate. A, atomic mass. So we need to work out the atomic or formula mass of these chemicals. We can ignore the big numbers at this stage. So I'll start with Mg because there's just Mg on its own. They've given me the mass here, it's 24, so it's dead simple. Over here we've got Mg and oxygen together. So to work out the formula mass, it's atom. You add the atomic masses together. So that's 16 plus 24 gives us a total of 40. Now obviously if you're having a bit of a stressful day, it is an exam after all, you don't want to make a silly mistake, pop it into your calculator, double check it. Right, we've got the mass, we've got the atomic mass. We next need to calculate the number of moles. To get moles we do mass divided by atomic mass, and we can't do it here, we haven't got enough numbers yet, we can do it here. So 1.2 divided by 24 gives us a total of 0.05 moles. Right, how do I work out the number of moles of magnesium oxide? I use R for ratio. I look at the ratio of the big numbers in front of my chemicals. Because the big numbers are the same, all that means is the number of moles are the same. So I simply write the number of moles the same in both cases. Now I need to use my triangle. So here's my question mark. This is what I've been asked to calculate. I need to work out the mass, okay, and in this case it's in tons. And to do that I can do moles times MR. Again, I've used more space than I have, but it doesn't matter. Okay, just keep showing you working out. Moles times MR gives you the mass. So we've got 0.05 times 40. Again, put that into your calculator. is 2. Check it twice. Okay, 2 tons, and then we see whether it makes sense. So does it make sense? That does make sense because we've only got magnesium left at the end. We started off with magnesium oxide, so that makes sense that you'd end up with less magnesium than the magnesium oxide that you started with. Sensible numbers within the same range. We move on, we've achieved 3 marks. Keep practicing. Don't forget that calculating the mass question that's worth 3 marks, be MAMRU. Keep practicing, happy revising, keep watching the videos.